So monitors also provide a solution to critical section problem. It is also used to provide a solution to critical section problem. These are high level language constructs, synchronization, high level language synchronization constructs, which are mainly developed to deal with the errors that are occurred with semaphores. Okay, so monitor abstract is an abstract data type. Okay, so you need to specify a keyword called monitor. Okay, so it is an abstract data type. You need to specify a keyword called monitor and with a name, monitor name. So here I will write dining philosopher because I am finding the solution for dining philosopher. So dining philosopher is my monitor name. Within the monitor there are several variables, that is all the shared variables will be declared within the monitors, and there are set of operations. Okay, that is per set of operations that are declared within the monitors. The variables that are declared within the monitor can be used by all these operations. Okay, so there is an initialization code we need to define within the monitor along with shared variables and these operations. We need to write initialization code also. Okay, so what are these variables? These are the variables, okay, that the variables and which states the actual state of the particular resource instance, that is whether the instance is available or not, or it is taken by someone, some other process, that will be identified by this particular variables, and what is the state of the particular variable will be known by using this particular variables. Okay, and the why this monitor, okay, and these variables and operations, the operations inside this particular monitor provides mutual exclusion property. Okay, so a function within the monitor can able to access the variables that are declared in the monitor. Okay, and the local variables of this particular monitor can be used by this particular function only. You cannot suppose that the function p2, okay, have some local variables a, b, and p1 have some local variables x and y. So and there are shared variables, let us take s1 comma s2. These shared variables can be used by P1, P2, and so on up to Pn. But x and y can be used only by function P1, and its local variables and function parameters will be used by P1. P1 cannot use the local variables of P2. Okay, and P2 cannot use the local variables of P1. Okay, and the main reason why we are implementing monitor is that within a monitor there is only one process that is active. Okay, so other processes which they wanted to execute critical section, okay, sub critical section, they have to wait because see, if there is p1 is a process, okay, which is inside the monitor executing inside the monitor, and the other processes may also execute critical section, they will execute their monitor code, but only one process at a time can execute this particular monitor. Okay, can active in this inside this within this particular monitor. All these processes will be suspended. All these processes will be suspended. Okay, so again, in order to suspend it, there is a operation called wait, and the in order to resume the suspended processes, we have an operation called signal. Okay, so along with this particular monitors and variables and operations, okay, monitor abstract data type, we need to implement one more data type or construct called condition construct. Okay, condition construct. This condition construct defines one or more variable of type condition. One or more variables of type condition. Okay, the syntax of this one is you need to write a keyword called condition space, you need to write a list of variables. Okay, so the only operation that is performed on this particular condition variables are x dot wait, x dot signal. Okay, so these are actually shared variables. These are actually shared variables. So the processes which wants to use these shared variables are shared resources. Shared resource instances. We can say that shared resource instances. We have defined x and y. Okay. So let us take a process P1 wants to use x. So it will invoke x dot wait. Okay, it will invoke x dot wait, and it is using the resource x. And whenever the process p2, okay, wants to execute x, wants to use x, then it also invoke x dot wait, but x is not available currently. Okay, x is not available currently. So what will be happen, there is a queue, there is a queue that will be added for this particular, okay, for this particular thing. So p2 will be added to queue. Similarly, p3, p4 also wanted to execute, then all those processes will be added to the queue. Okay, so whenever this particular p1 executes x dot signal, execute x dot signal, the first process in the queue, that is in that wants to, that is in x queue, will be resumed and allowed to use x, resource x. Okay, so that is how condition constructs are used. They are shared resource instance variables. Okay, so x is used to suspend the process and put it on the queue, and signal is used to resume the process and release from the queue. Okay, delete from the queue, and it will be allows the next process to execute, use that particular x. So similarly, this wait will provide mutual exclusion, and signal always provides progress and bounded waiting, the amount of time that one particular process or number of turns a process will wait. Okay, so this particular monitor provides a deadlock free solution. Okay, this will provide solution for dining philosopher solution problem. Okay, so here the restriction is that a philosopher may pick up his chopsticks only if both of them are available. If one chopstick is not available, we are not picking up. That means before picking up, we are checking that whether left chopstick and right chopstick both are available. If left chopstick available but right chopstick is not available, we are not going to picking up. Similarly, if right chopstick available and left chopstick is not available, then we are not going to pick that particular uh, chopstick. Even though one chopstick is available, we are not going to pick it up. Okay, so next we have already said that philosopher have three states. Okay, first one, thinking, hungry, eating. So he will think whenever he will get hungry, he will tries to eat the food. Okay, rice. So I'm taking a construct enum, thinking, hungry, eating, and every philosopher has three states. There are five philosophers, so I'm taking this one. Okay, so next we need to write a condition variable called self. Okay, because this particular condition variable that is used to suspend the process when the chopsticks are not available. Okay, right. Next, the condition for eating. What is the condition for eating? Let us take this particular P or P0. Okay, P0, P1, P2, P3, P4. And this is C0, C1, and C4, C2, C3. What is the condition for eating? When P0 wants to eat, he needs to check P4 is not eating as well as P1 is not eating. If P4 is not eating and P1 is not eating, then both the chopsticks are available. Okay, then both the chopsticks are available. So that is the condition for P1. The condition for here. So we need to check what is the state of P4 and also the state of P1. Okay, and he has to be hungry. He has to be hungry. So this is the code that is given for solution for code that is given solution for critical section problem for dining and dining philosopher problem. Okay, so what is the initialization code? First, initially all the philosophers are thinking. Okay, initially all the philosophers are thinking. First, here there are three things that we have to follow. First one, three steps that we have to follow. First one, we need to pick up the chopstick. After picking up both the chopstick, then we start eating. Then once eating is finished, then you need to put down both the chopsticks. Okay, so pick up, we need to pick up both the chopsticks and we need to put down both the chopsticks after eating. So this eating will comes under critical section. Okay, so this is the code that is given in this particular here. So let's sequence serial code. Let's divide this into different parts. Okay, so if I divide this into different parts, so I have given state of I equal to thinking for all the philosophers. Okay. Okay, so let's see this one. Let us take philosopher P0. Okay, wants to eat. So initially state of phi declares that all are thinking. So what is the condition for picking up? First one, state of 0, that is philosopher 0. First we need to set state of 0 to hungry. So state of 0 to hungry. Then we need to invoke this particular function called test function. Okay, the test operation. Now the control goes to test. Okay, and it will check state of 0 plus 4, that is state of 4 percentile 5, that is state of 4 not equal to eating. So it is not equal to eating because it is thinking. Okay, now state of I equal to hungry, state of 0 equal to hungry, yes. So this is yes and this is yes. And let us take state of 0 plus 1, that is state of 1 is also not eating, yes, it is also not eating. So all three conditions are true. Then state of I, okay, here comes to state of I, so state of 0 to eating. Now I am changing state of 0 to eating and it will implement self dot signal. So there are no self dot signal. Now after this particular statement, it will again go to this one. Okay, so this is a condition for eating, this is a condition for eating. Now after eating, after P0 finishes its eating, he will again change this particular state of 0 to thinking. Okay, he will change this particular state of 0 to thinking and invokes in this particular, okay, put down function. It tests that check test of 0 plus 4, that is 4. Okay, 4. So test of 4 will be taken this one. Okay, execute this one. That means this put down operation allows other process to eat. Okay, it is allowing other process to eat. Suppose the test of 4 is not feeling hungry, test of 4 is not feeling hungry, then what is the state of test of 4? Thinking. So this one, state of 4 is not eating, sorry, state of 0 is not eating, state of 2 is not, this one is also not eating. Okay, for 4 P4, this side P0 is sitting and this side P3 is sitting. P0 is not eating, P3 is not eating, but P4 is not hungry. Okay, so this function will be, this will not be executed, this will not be executed, but P3 is hungry. Suppose that P3 is hungry, he will check for P2 and P4. P2 is not eating, P4 is not eating, and P3 wants to eat. Okay, hungry, then he can eat. Suppose that P2 is eating and P3 wants to check. So P2 is eating, then P4 is not eating. Okay, P4 is not eating and it is feeling hungry, but this condition fails here. Okay, this condition fails. If any one of the condition fails, then P3 has to wait. Okay, so this is how the code is implemented. Okay. Okay, so advantage of monitor is we can avoid deadlock, but there is one problems with monitor, that if we use monitors, there is a problem of starvation, because until and unless one process will enter into monitor and it is coming out, no other process can do anything. Okay, they have to wait. So starvation is a major problem with monitor. Other than starvation, okay, here if you use monitor incorrect use of monitor leads to several problems. That is, a process might request the same resource twice, first without first releasing it. Okay, similarly a process might attempt to release the resource, it is never requested. Okay, so a process once releases, it is granted, it has been granted to the never released, and it will be granted to that particular process. Okay, that is also not correct. Okay, so this monitor can be problematic also. Okay, and there is a problem that a process might access the resource without first gaining the access permission to the resource. Okay, so these are four problems, and major problem is starvation with the monitor. Okay.